Well, good afternoon, everyone, and welcome back to our fourth and final webinar for today and the first day of our webinar series 3. If you're like me, you're peeking out the window and you're checking the temperature because it looks pretty nice outside, and I don't know about you, but I'm looking forward to catching some sun with my kids this afternoon and playing. So, but before we do that, we have one final webinar today, and looking forward to hearing from our presenters. Like always, our presentation will last roughly 40-45 minutes. We'll leave some time towards the end for Q&A. Please don't forget to use the chat function to submit your questions. Use the little drop down, select AIEC, direct those to Brian and myself. We are AIEC, by the way. I think sometimes I forget to mention that. So if you're looking for Dan and Brian, we're not there. We're under AIEC, and those will come directly to us, and we'll moderate those questions to our presenter on your behalf. Also a reminder, if you've missed any of our previous webinar weeks, those are available to you at aiec.coop/webinar weeks, and then click the archive link, and you can go through and browse those and view them at your leisure. And Brian, I'll turn it over to you.
All right, just a reminder to those attendees that are looking to acquire PDH credits for their professional engineering license. This session does qualify for that, so be on the lookout for those certificates to come at the end of Series 3, which should wrap up around March 30th. So I'll be keeping track of all the sessions you attend and making sure you guys get the credits you need. Our presenter today is David Bremmer. He joined Richards Manufacturing in 2014 as their Western U.S. sales manager. He started his career as an applications engineer with the energy division of Raychem Corporation in Menlo Park, California, primarily involved in a variety of low and medium voltage cable accessories. So with that, I will hand it off to you, David.
Great. Thank you, gentlemen. Good afternoon, everyone. I hope everyone is doing as well as can be expected, not only with the pandemic, but with some of the extreme weather events that have hit the country. And first and foremost, I hope you're all doing well. Thank you for hosting me today. Today, the presentation that we're going to embark on is really a discussion on Richards manufacturing medium voltage cable accessories and some advancements in product designs that have been accomplished over the last few years. And I think we'll kind of keep it as open forum as possible. If it's simple to ask questions during the presentation, I'm happy to try to field them as we go, or if you want to wait until the end, that's fine as well. So with that, this will just give you a little background information about Richards Manufacturing. It's a privately owned manufacturer. They have been in existence since 1944. They started out manufacturing really split copper sweated connectors for like splicing copper paper lead cables. But over the decades, they've definitely expanded their offering. They're located in Irvington, New Jersey, and then they've got a polymer compounding plant in Chardon, Ohio, and they're vertically integrated manufacturing. What we're just trying to say there is that they do a lot of the design, development, raw materials, polymer compounding, all the way to finished goods and testing. So they're very adept at controlling their destiny on their product line. They've got 3 primary electrical product lines. One is medium voltage cable accessories, and that's really the focal point of our presentation today. And then another is connectors. They have a very broad connector offering of both overhead and underground connectors. And then their third electrical product line, which we're not really going to touch on today, is network protectors, network relays, and communication systems for secondary network systems. I also wanted to mention that they do have a natural gas distribution product line. It's handled by a totally separate sales organization and within Richards. So we're also not going to touch on the natural gas products as well. And currently they employ about almost 400 people now. So I know the slide says 350, but they've grown since. I wanted to share one slide on their connector product line because it's broad, and I know almost all the folks probably on this call will have application for some of these connectors. They do both tinned aluminum as well as tinned copper or bare aluminum, bare copper compression connectors. They do a lot of bolted connectors. They do hotline clamps, stirrups. We're not the largest connector manufacturer in the world by any means, but they tend to inventory a lot of hardware, and they tend to be very nimble as far as their connector product offering. And what I'm trying to just say there is that it doesn't take tens of thousands of connectors to get Richards to develop something new or to modify or design something custom if there's some specific needs you're looking to fulfill. And if you're ever in a pinch as far as not being able to get connector products, please give us an opportunity to try to fill your needs. One of Richard's strengths is just inventory. They carry a lot of inventory, and they're committed to this business. And I think they can surprise a lot of people as far as what they can deliver. So that's just one slide on our connector products. Really, the focal point of this presentation was to kind of discuss our medium voltage rubber goods. And Richards has a very traditional dead brake rubber good offering. On this slide, you can kind of see our 600/900 amp dead brake elbows, cable adapters, compression lug, cold shrink tube offering. They're qualified to IEEE standard 386. We have them at the 15 and 25 kV system voltage level, which is covered by the same elbow. And then we also offer these up through 35 kV, which has slightly larger bushing interfaces. So it's a slightly larger elbow. We do all the cable adapters, the compression lugs. These are 100% production tested. IEEE standard 386 requires 2 out of 3 voltage withstand tests on the production of units. Richards, of their own volition, does all 3 voltage withstand tests. And then we've seen some customers where at 35 kV system voltages, they're asking for a higher than standard BIL level, which is a 200 kV basic impulse level. And we can accommodate that higher impulse requirement as well. So that's a very standard, dead brake elbow, 600 amp, 900 amp dead brake elbow offering. We manufacture a lot of the standard plugs, whether they're maybe the more traditional reducing tap well with bushing inserts, or elbow tap plugs, or load reducing tap plugs, insulating plugs, connecting plugs, compression lugs, cable adapters. There's a whole variety of plugs that go with 600 or 900 amp systems, and we manufacture many of them. Not all of them, but many of them. And then this is almost like, I don't know what you would call, almost like a family tree of our dead brake product offering. So I don't want to go through all the parts and pieces in this, but we just want to mention that we're a pretty full line supplier when it comes to dead brake elbow systems. I want to mention in the lower right-hand corner of this slide, you'll notice that there's a load brake elbow shown. And Richards does manufacture a 15 kV, 200 amp load brake elbow. But we don't, it's not what we would really consider within the wheelhouse of our product line. We tend to, we manufacture that item and stock that item and sell that item yearly, but there's 5 other manufacturers of load brake elbows. So we're not necessarily pursuing load brake elbows as our first and foremost offer for the marketplace. The reality is you're probably going to find another manufacturer out there that's available and lower in cost than us, However, we tend to sell load brake elbows every year because we carry inventory. And so just be aware, we do have 15 kV load brake elbows, even though we may not market that item as actively as we do some of the other items. All right, which brings me really to this slide. And about 6 years ago, Richards introduced what we call the CSH, which stands for Cold Shrink Hammerhead. And this is a cold shrinkable 15/25 kV rated 600 or 900 amp dead brake elbow. About 2 years ago, we introduced the product on the right, which is called the CS8. And that's called the Cold Shrink R800. It's a cold shrink dead brake elbow with a factory integrated 200 amp load brake tap plug. So the reason they came up with 8 was because it's a 600 amp dead brake elbow with a factory integrated 200 amp tap plug. So that combination was 800. That's kind of how they shortened that up to be CS8, but these are both cold shrink dead brake elbows. And I'm going to back up just a couple slides here quickly. This product line here, so Richards has been manufacturing dead brake elbows for about 25 years. And this is traditional pre-molded push-on style dead brake elbows that use cable adapters and compression lugs. But this product line, the pre-molded dead brake elbows, they've been on the market for about 50 years. And really, over that 50-year span, there had not been a whole lot of innovation achieved on this very basic pre-molded elbow design. So one of the nice things about this cold shrink dead brake elbow is it allows us to minimize the number of parts and pieces involved, reduce the number of interfaces involved, and these interfaces have to be kept clean and dry and free from contaminants, establish something physically easier to install, and really have a product that's maybe ergonomically more attractive than its predecessor. So, okay, this will kind of give you an idea of the comparison of a cold shrink elbow versus a traditional pre-molded elbow. So these cold shrink elbows are range taking. They can accommodate multiple cable sizes, and we can marry those with a range taking shear bolt lug. So now we can have one box that can handle multiple conductor sizes and cable insulation diameters. So previously you had size specific compression lugs, and you almost have a compression lug for every conductor size. And then you have, cable adapters, which is the component underneath this compression lug. And again, those might accommodate 1 or 2 cable insulation diameters, maybe 3 insulation diameters. But to be honest with you, most utility companies, it's almost like they have a cable adapter for every cable size. They're push-on pre-molded components, so it might be easy to install on one size cable, but then become very difficult to install on another size cable. And then the very bottom piece here we're showing is a cold shrink tube. This cold shrink dead brake elbow here, it has a factory integrated cable jacket cutback seal. So you'll see some slides later in the presentation that will illustrate that more effectively. Okay, again, one of the things that we're trying to emphasize is we're eliminating the cable adapter in its entirety. In this slide, you're going to see a photograph of a cable adapter. In the bottom, approximately 25% of that cable adapter is a conductive stress cone. So it's made of a conductive polymer. The balance of this cable adapter piece is a dielectric rubber, so an insulating rubber. So long story short, these cable adapters have to be located properly on the cable. If they are not driven onto the cable far enough, that can become an electrical problem. If they are overdriven, so pushed onto the cable too far, that can be a problem. So they're location sensitive. These cold shrink dead brake elbows, there is no more cable adapter. The cable throat, which is kind of from the middle of the elbow to this orange looking ring, that's a shrinkable interface, and it has a built-in electrical stress control feature. So all you have to do, if you line this up onto the lug and the stud properly, you will get this shrinkable feature into the right zone on the prepared power cable. So it eliminates the cable adapter piece in its entirety. And for those of you that are familiar with cable adapters, they have to be lubricated on the inside. So the cable insulation surface has to be greased. And then the outside of this cable adapter piece also has to be greased. And then you got to make sure that this lubricated component doesn't slide out of position. So it's a reliability concern that, usually folks that have installed, thousands of elbows have experienced an issue with location. All right. Okay. In this slide, what we want to communicate is that these cold shrink elbows from the middle of the elbow upwards towards the bushing interfaces and the plug interfaces, that is a standard IEEE 386 dead brake elbow. So those are standard interfaces. The nice thing about that is that all the existing 600 amp or 900 amp bushings, or all the existing plugs, whether it's an insulating plug, a tap plug, a connecting plug, all those plug components that you have in stock on your trucks deployed in the field will fit this elbow just like it will fit the dead brake elbow, the pre-molded dead brake elbow that's been in use for 50 years. What's different about this is really from the middle of the elbow downwards, which makes this a shrinkable elbow and has a factory integrated jacket seal. So same bushings, same plugs, same tools, same torques to install this elbow, just like your traditional pre-molded elbows. Okay. All right. I wanted to include a slide also talking about the CS8. This is the version where it's got a factory integrated 600 to 200 amp tap plug. And this plug installation we've seen become more and more common in the utility industry. And usually it's a function of people want the ability to either piggyback a surge arrestor or piggyback a load brake elbow, or they're going to cap the position and they want access for direct testing. So a lot of times we'll see customers where they're deploying elbows and switches and they put tap plugs in there just for those very reasons. So in this case, we've got, a tap plug, a dead brake elbow, a compression lug, a cable adapter, a cold shrink sleeve, and that can be replaced by a integrated tap plug, cold shrink elbow with a range taking shear bolt lug. So again, it affords an opportunity for SKU reduction or part reduction, fewer interfaces. And when we talk about interfaces, we're talking about the phased ground interfaces that have to be lubricated and assembled in the field, and they have to be kept clean and dry and contaminant free. And these cold shrink elbows are 100% production tested before they ship. This is just I think I've mentioned the products are range taking. In this example, we had an investor-owned utility shared with us 16 different cable SKUs that they have that are in operation in their system. And we were able to accommodate all 16 of those cable SKUs with 2 cold shrink elbows. So otherwise, they'd have had a multitude of cable adapters and jacket seals and pre-molded elbow to accommodate all these different cable sizes. But in this in this examination, we were able to do all 16 of those codes with 2 elbows. We've got 5, so there are actually 3 elbow body sizes. We call them O, P, and Q, that will cover between about 15 kV, number 2 or 1/0, all the way through 15 kV, 1250. There's 5 shear bolt lugs that will do the same thing. They'll get from, number 2 all the way through 1250. And we can probably do it with even fewer than 5 lugs, but sometimes, depending upon the combinations of conductors that folks are operating, there's some advantages, some cost reduction advantages by having a slightly smaller range on some of these, with just keeping material costs down. On the photos that you see on this slide, you're going to notice on the left, you'll see like these bolts are protruding from the barrel of the shear bolt lug. On the right, those bolts have been sheared and caps have been placed over the indent left by the shear bolt lug. And we've done testing on these shear bolt lugs. We've had really good results from the shear bolt lug performance. They've been qualified to IEEE 386 for both 600 amp or 900 amp applications. They can be used on copper or aluminum conductor, and they pretty much pick up all strand configurations within any specific conductor size. So for compression lugs, an example, you would have a 4/0 compact compression lug is typically different than a 4/0 Class B compression lug. And they're both 4/0 conductor, but just the different strand configurations drive different compression lugs. And these shear bolt lugs are range taking and can cover a broad variety of conductor. Okay. One of the biggest benefits, and this is sometimes can be hard to quantify, but really it's the ergonomics of it, not having to drive on pre-molded push-on components. And for traditional pre-molded elbows, you've got to drive on these cable adapters and the elbow body. And these don't necessarily slide onto the cable substrate easily. I mean, sometimes you really have to get into an ergonomically strong position to drive these pieces onto the cable substrate. And sometimes you're just not afforded easy access to the cable. There's either other cables in the way, or you're working inside of a switch cabinet where it's not necessarily easy to get your body in a strong position to drive these pieces on. So one of the biggest benefits of these cold shrink products is really going to be from the ergonomics perspective. This is a fairly dated slide, but it's from California Department of Health Services report back in 2001. And there's a issue called musculoskeletal disorders, MSDs. But MSDs, and this is kind of like back, shoulder or wrist injuries. On this report, they said MSDs accounted for 34% of all lost workday injuries. And back then, more than 620,000 lost workday MSDs were reported each year. So that's across the country. And MSDs were accounting for $1 out of every $3 spent for workers' compensation. And back then, again, this is 2001, $15 to $20 billion in workers' compensation costs. So it can be significant. And if any of you have experienced, back injury or shoulder injury, you know how those can be recurring events that, once it happens to you, the risk of occurrence can, go up as well. So trying to avoid that can be a major benefit for your workforce. All right, these elbows are fully submersible, so they're designed in operation subsurface, as well as they can be pad mounted or installed above grade. And we've got designs and accessories that can be added to these elbows that will allow them to accommodate all the major cable metallic shield configurations. So jacketed concentric neutral cables and flat strap neutral LC shielded cables, those are all common in the utility industry, but they can also handle copper tape shielded cable or drain wire shielded cable. We've got versions of these cold shrink elbows that can accommodate every major cable metallic shield type that we see in the industry. And I think I've already mentioned that these are 100% production tested. Okay. It really kind of addressed the comments that we wanted to share about the cold shrink, the development and in the innovation of the cold shrink elbows, cold shrink dead brake elbows. This next section is kind of talking about splices. And we wanted to discuss a little bit about inline splices, and then also maybe a little bit more about a disconnectable splice offering that continues to gain popularity as well. So that's kind of be covered in this next section of the presentation. But there's many ways to make a cable splice, and there's many materials that can be used, all the way from hand tapes to pre-molded products to heat shrinkable products to cold shrinkable products. There's resin kits out there. There's field formed products out there for different applications. So there's just there's a whole variety of different styles of products that can be used for splicing. But this shows just a couple of them out here. Cold shrinkable splices, we've seen definitely some trending to cold shrinkable solutions, just because they're range taking. They tend to be physically easy to install, or easier to install compared to some technologies. And they can be factory production tested. Disconnectable joints, the second one down, we see them gaining popularity because it's people continue to demand more from their cable accessories in the strategy of being able to reconfigure. So where at one time you had an inline splice, now you want to tap off of that location, but you don't want to have to necessarily cut the entire splice out and redo the whole thing. So we see disconnectable joints continue to gain in popularity. Dead brake elbows can be used to create a multi-way splice connection. And we do see this. This is not uncommon, where you see folks that are using stacked elbows to basically build a two-way or an inline splice or a three-way or a four-way. I think we've probably seen up to 6 ways deployed in the field, although I don't know that that's recommended because the stack starts to get so tall. Junction bars with elbows are popular as well, where you might mount a junction bar in a either pad mounted or below grade structure, and then basically it's a bus bar with a bus bar that you can land multiple cables onto. So there's a lot of different ways to do splices in the market. But we wanted to chat a little bit about the cold shrink splices. And Richards introduced the cold shrink splice about 8 to 10 years ago. And it's the only range taking cold shrink splice that we've seen on the market here in the US that offers a capacitive test point feature. It can be provided with a range taking shear bolt lug, and these splice bodies are range taking too. So again, we can marry a range taking connector with a range taking splice body and really have a box solution that covers multiple cable sizes. If you have the ability to see this slide and can see this shear bolt connector, you're going to notice that there's a groove that's cut into the center of the connector, and that groove mates with a proud ridge that's molded into this cold shrinkable splice body. That proud ridge will catch this groove on the connector and it helps the installer identify that they found the center of the splice or the center of the connector. One of the ways we've seen, just in general, installers get off on the wrong step with cold shrinkable products is when the products are not properly centered. And this helps the installer identify that they've found center. So that's what that cut groove is in the center of the shear bolt connector. This just shows the installation where they've got a splice. One splice has already been installed. The other splice is just getting the shear bolt connector, having the shear bolt connector installed. One of the nice things about these shear bolt connectors or lugs is that they can be successfully installed with battery-powered impact tooling. A lot of these impact tools weigh in the 4 to 6 pound range, and many times we see utility trucks are already outfitted with those tools. So they can get to a battery-powered installation on a connector without a installation tool that costs thousands of dollars. You know, I would say in general, we see utility grade impact tools run in the $400 to $500 range, whereas battery powered compression tooling, sometimes that's $1,500 to $2,000 to $3,000 or more just for the tool to install compression. So you can install these shear bolt connectors with impact tooling, or if you don't have access to that, you can do it with standard hand sockets. And in this slide, we also mentioned the centering indent that I already discussed. And then one of the things unique about this connector design is these shear bolts, the remainder of the bolt will shear below the surface of the barrel of the connector or lug if you were doing an elbow installation. So it's just a feature of the shear bolt connector. Will shear below the plane. So there's no sanding or filing required to address these sheared bolt heads. Okay. All right, this is really just showing, this is kind of what it looks like installing one of these cold shrink splices. The splice is parked on the cable far back enough so that mastics and grease can be applied over this substrate from cable semicon cutback to cable semicon cutback. There's not a whole lot of parts that have to be parked onto the cable substrate. And that keeps the installation relatively, clean. Here, looks like all of these, I can't tell if these ones did, but at least 2 of these installations went in with capacitive test points. In this case, they just bring the neutral conductor out and around the splice body. Or if it was some other shielding like flat strap or LC shield, they'd have a separate jumper that they would attach to that shielding, and then they would bring that out and around to continue the metallic shield of the splice. This is on the disconnectable joint offering that I had mentioned. So really, in this slide, you'll see a Y splice, but there's an I splice, which would look just like this, except it would have no third position on the top. What you see here is a Y. There's an H, which is a 4-way. There's a U, which is a 2-way, but both the cables are landing onto a bus that's shaped like a U. Sometimes people will refer to that as a stub configuration. There's a new E bus, which is basically a 6-way. So it's 3 positions on the left and 3 positions on the right. And then there's also an L bus, which is for somebody who's trying to build a splice in a corner or off of a corner. So those are different bus configurations that are on the market. These disconnectable joints are suitable for use up through 35 kV. There's 0 blind conductor connections. I'm going to discuss that a little bit more in another slide or two. And fewer parts and fewer exposed interfaces versus other options. I'm going to have another slide that will discuss that further. This kind of does a comparison between dead brake elbows and a cold shrinkable Y joint. Now we manufacture dead brake elbows, so I'm not saying that dead brake elbows can't be utilized effectively to do a three-way splice. They can. But some of the benefits that you'll see from this disconnectable joint offering is just a reduction in the number of pieces and a reduction in the number of interfaces, and then 0 blind connections. And that's whether you were using our dead brake elbows or some other brand of dead brake elbow on the market. But in this comparison, you've got 18 pieces trying to do a three-way with dead brake elbows, 12 interfaces, and 3 blind threaded connections. And what we're trying to say there is that the installer just can't physically see the threaded stud going into the receptacle. So it's done by feel, like it feels like it's threading on correctly, but it's not, you can't visually confirm it because it's captured within the rubber housing. For these disconnectable joints, the installer can physically see the bolt go through the eye of the lug and into the receptacle threads of the bus. So there's nothing preventing that visual confirmation. If you're doing a height comparison, this is just 29 inches versus 9 inches of stack height. And as our cities and our distribution systems build out and grow, many times the vault or manhole wall real estate is as valuable as other pieces of real estate because they're trying to load more circuits in there. They're trying to operate bigger cables. They're trying to push more amps through any given conduit or duct bank that they had as already existing. And having lower profile solutions can oftentimes be a major benefit from a available workspace perspective. There's a product on the market called the Elastomer vault stretcher. This is an option to do a 4-way. And again, with this vault stretcher, you got 24 pieces, 14 interfaces, 3 blind threaded connections. Trying to do a 4-way with a H-bus, you've got 13 pieces, 8 exposed interfaces, and again, 0 blind threaded connections. 4-way still has 9 inches of stack height, same as the Y-splice. Right? One other thing I wanted to mention is if you're doing an installation with stacked elbows or with like vault stretcher, and that like if you're using our stacked elbows, it's the same way. Once you start unbolting the stack, you're unbolting the entire stack. One of the nice features of these disconnectable joints is you can engage any single position without impacting the torque or the seal on any of the other deployed positions. So it can kind of help minimize rework or retorque. You know, once you start unbolting a stack of elbows, you've got to go back and retorque each interface. And if you don't do that, you run the risk of having an improperly torqued assembly. So that's one of the nice features about these disconnectable joints. Again, we can use range-taking shear bolt lugs, just like with the other products that we've already discussed. Over the years, we developed a component called a barrier bolt. And what was happening with one of our customers was their crew would actually install the lug to bus connection, but they potentially would forget to torque that bolt. And then they would close the sleeve onto the bus with an untorqued connection. So they developed this barrier bolt, which is a twin-headed bolt with a plastic separator in between. So it prevents an installer's ability to close a sleeve onto a bus until this upper, or in this at least photograph or slide, lower bolt head has been sheared off. So once it's been sheared off with the right torque, then they can close the sleeve onto the bus unit. All right, and it's a barrier shear bolt, so it's a shear head bolt. Will shear off at the right torque onto the bus piece. This is just an example where we're talking about the blind connections. Here you can kind of see a bolt that's already through the eye of the lug that's going into the bus piece, physically visible to the installer. Here they've sheared that barrier bolt and they've closed the cold shrink sleeve onto the bus. There's about a 3-inch push-on interface that this cold shrink sleeve has on the bus unit. So for decades, they had pre-molded versions that you almost had to use either lever action or bolt action tool to drive these sleeves on. But now that they're cold shrinkable, they become physically much easier to install. Okay. In this photograph, you can kind of see the holdout core. This sleeve has been shrunk on the cable substrate, and the holdout core, which is this clear plastic piece, is sitting on the cable substrate. Okay, it's been shrunk. The nice thing about these cold shrink sleeves is they tend to conform with the cable substrate. So in this photograph here, you see a customer where they've got a feeder cable and they've got a tap cable. And the tap cable is going off to, I think it was a transformer load, but it's curving downwards towards the load, and the cold shrink sleeve contours with the cable substrate. So it's not like a pre-molded component necessarily where it wants everything straight and true. These will, bend with the substrate that they're deployed upon. These cold shrink sleeves and bus units can be used to do size transitions. This was a 35 kV size transitioned at a wind farm, I think in Ohio. It was interesting. They utilized a pop-up tent to create a protected work environment because it's at a wind farm, so it's windy, and this was a direct buried installation, so they had loose soil around, and that was an interesting note. But this was a 35 kV 1250 to 1500 size transition, and these are suitable for direct burial. They're suitable for subsurface installation. This was some eye joints also installed at 35 kV. We have what's called a covered neutral jumper. If any of you are in environments where bare neutral conductor will just corrode and be eaten away within, a short, undesirable amount of time from post-installation, we have covered jumpers that can be used. It's almost like insulated conductor, but they're covered jumpers. They're very flexible. They're designed on rope lay copper, and that's what you see coming out of these joints. These joints are going to be probably submerged in water, and they wanted to protect these jumpers from corrosion. One of the nice things about these disconnectable joints is you can engage any position without impacting the torque or seal on the other positions. So a lot of times it allows you to do, mainline feeder work at, one part of the year. And then once your developer or your customer load is ready, then you can, or you could cap tap positions until you're ready for them to be utilized. So in this photo, they did the mainline feeder work, but they capped tap positions, so tap conductor positions, until they were ready for them. And then all they have to do is come back and remove those taps and land the load cables to this Y joint. This is in Hawaii. I wanted to show this photo just because this shows sacrificial spiking stems. So what you see on the right here, these yellow banded items, that's a sacrificial spiking stem. So this H bus, it's got a mainline feeder, it's got a load tap cable, it's got capacitive test points, and it's got sacrificial spiking stems. So it gives the operator multiple means to evaluate the condition of the circuit before they actually go to work on it. So they can use capacitive test points, they can test for voltage, they can test for no voltage. And then even before entering the structure, they can use either remote cutters or remote spiking tools. And this spiking stem is a sacrificial piece that can be replaced. It's got a copper rod that's insulated and shielded in insulating and conductive rubber. This is just the installation on a fully loaded H-bus. 12 cable ends there, but it kind of gives you an idea of the low profile feature of these disconnectable joints. This was an interesting slide in that they just oriented the spiking stems in alternate directions, just to give their people more access to the spiking stem piece. This is a fully loaded 6-way. So again, mainline feeder, 2 taps, spiking stems, and a spare position. That was really the intention of what we wanted to cover for this presentation. So I didn't know if there was any questions that may have come in for during the presentation, but I just wanted to maybe open it up for questions at this time.
Thank you, David. We have had a few questions come in. The first one is, has Richards looked at developing a cold shrink load break elbow?
Yeah, that's a good question. We've had customers inquire about that multiple times. At this point in time, they have not developed a cold shrink load break elbow. It seems like I think one of the barriers is the load break elbows tend to be fairly low in cost or purchase price in general. So they're concerned about the deviation between the cost of a load break elbow and the cold shrinkable load break elbow. So not yet, we haven't. Still there?
Can you hear me?
Okay, gotcha.
Oh,
yes.
sorry, I must not unmuted. The next one that came in, are you seeing medium voltage cable applications going into utility/renewable power systems sized at larger than 1,000 kc mil?
That's another good question, and yes, we're starting to see 1,100 has become, which so 1,000 kc mil, we see it routinely. We're starting to see, and by starting, I should say, probably over the last 10 or 15 years, really, we've started to see 1,100 kc mil come up more commonly. We're starting to see 1,250 kc mil come up more commonly. And then really within the last 1 or 2 years, we're starting to see 1,500 kc mil coming into the medium voltage realm. Maybe more so in renewables right now, but there's certain utility companies as well that we're starting to see them go to cables as large as 1,500. And this is for medium voltage applications.
All right, a couple other questions have come in. Has there been an increase in adoption of shear bolt style connectors in the electrical power market in general?
Yes, I would say there has been. Certainly I can speak from a Richards manufacturing perspective. I know our volume, and if I just looked at our volume over the last 7 years, our volume has been steadily increasing on the supply of shear bolt connectors. But then the other thing that we see is that almost all of our major competitors have a shear bolt connector or lug offering. So if we looked at like ABB or Cooper or 3M, pretty much all of them, along with ourselves, have shear bolt connectors and lugs. So it's almost a telltale sign when you start to see multiple manufacturers going in that direction. I think we're probably all seeing more and more adoption of shear bolt technology.
All right, last question for you. What resources can be adopted or utilized to aid in medium voltage product installation reliability?
Gotcha. Another good question. I think a lot of reliability, so this is field assembly of components that are going to be energized at, what we call medium voltage, but a lot of people would consider very high voltage. And they tend to be susceptible to issues of, cleanliness, contamination can be concerned. So trying to make sure that the folks are, almost taking the time to work clean, to utilize tooling. We've seen, one of the things we've definitely seen adoption, especially I think, utility and renewable both, is more and more folks are going to more specialized cable prep tools. And what I'm trying to say there is, like, for years and years, people would use a knife and pliers to prepare power cable. But, and it could be done successfully with a knife and pliers. But mistakes could also be made with a knife and pliers. So more and more folks seem to be adopting specialized cable preparation tools that help their installers control the depth of certain cuts as they go to prepare power cable. And I think that is definitely one of the things that can be deployed to help ensure, quality cable preparation. It doesn't matter what cable accessory you use if there's if the cable preparation has been compromised. So those are some things that I think could be done to help ensure reliability. And then the other part of just taking the time to make sure things are lined up, they're clean, they're threaded, they're greased. Sometimes, maybe there's too much pressure on productivity, or I don't know. I guess I would defer to the utility folks on the call, but making sure that people aren't cutting corners on the time aspect of training the cables properly and keeping everything as clean as possible. So.
Well, thank you, David. I don't think we have any further questions. I want to thank you for your time today. Hey, if you have a contact slide, do you mind throwing that up? Or if not, just give a quick shout out so that people know how to get in touch with you if they need to. Obviously,
Yeah.
They can always reach out to us, but always like to be able to put your contact information out there.
Gotcha. Shoot, I should have. I'm trying to think if I have a contact slide. Can I send out the info? Would that be okay? I didn't put a contact slide in there. I apologize.
Absolutely. And like I mentioned, if anyone's interested in reaching out to you, please reach out to myself or Brian, Ashley as well, and we can make sure to get you in contact with David there. So again, thank you very much, David. That was
thank you all, and be safe and take care out there. I know there's lots of things going on in the world, but we wish you all the best, and everybody take care out there. Okay.
Yeah, we appreciate your time today. Hey, if you're not doing anything next Tuesday, Tuesday the 9th, that will be our second installment in Series 3 of AIEC Webinar Weeks. Be on the lookout for an agenda from Brian Adams. He'll be sending that out before too long. You'll be able to go out to aiec.coop/webinar weeks and register for those. And I'm sure we'll have some additional webinars in the next round with that are eligible for PE credits. So be on the lookout for those. And with that, that concludes our final webinar for today. Thank you all so much for attending.
Thank you.
Thank you.